Now that we know the different types of solution sets that exist, let's go ahead and get into the first example. So the question is, find the value that satisfies the equation, so we're looking for the solution, and use mathematical tools to identify the solution. Present the answer in set notation. So this is an alternative way to solve that's different than the way we learned in lesson 2.5. This is a way that involves using mathematical tools, specifically the graphing calculator. So our first step is to identify the variable expression. And so we have an equation that has a variable expression on both sides. So our second step is different. Now instead of making a number side and then eliminating the variable on the number side, our second step is to use the addition or the subtraction property of equality to simplify one of the expressions to 0. So now we're going to have a variable side and a 0 side. And when I say simplify one of the expressions to 0, I want you to recall the additive inverse that we learned about in lesson 1.4. So we learned that when you have a number, for example 5, and you add the opposite of that number, negative 5, those numbers are additive inverses, so they will always add up to or simplify to 0. The same thing was true when we have a number like 6, and we subtracted the same value. These numbers will always subtract to 0 if they are the same. So what we're trying to do is create one of these expressions as a 0. So let's make this the side or the expression we want the 0 on, and we'll leave this side as the variable expression. Now, if we want this expression to simplify to 0, then we can either add the opposite of it, or we can just subtract the same. So that's exactly what I'm going to do because it's easier. I'm going to subtract this expression from itself, and it can be rewritten like this. So I've subtracted the expression. So the expression was negative 150 minus 99p. So I've got negative 150 minus 99p, and I've subtracted it from the left side. And this is the subtraction property of equality that allows me to subtract this from the left side. Well, by the definition of the property, if I subtract that from the left side, I must also subtract the same thing from the right side. This is keeping the scales even, right? And so now we can simplify, and we know that this left side is going to simplify to the value we want, which is 0. Now the right side, we don't need to simplify. We can just leave it like this. So I'm just going to rewrite it the same. Because we're using the calculator, is no need to simplify. The calculator will do all the work for us. So now that I've got 0 on one side, I can move into step 3. So step 3 is type the variable expression into the graphing calculator. So I'm going to pull up the graphing calculator, and most of you guys will see scientific first, so we go to the graphing feature, And here's our expression bar. So we're going to type in this expression into the graphing calculator bar. So I've typed this expression in the graphing calculator bar, and you're wondering, why do we have now an x when our variable is a p? Well, the graphing feature does not have a p variable, so we're just using the x variable in the p variable's place. It's still a variable, so we're okay. We just know that x is actually p and y is actually 0. So now when we use this feature, we're trying to find the value that makes the right expression equal 0, because if we have 0 on both sides, we've got an equation that is true. So we can go ahead and hit graph. Now we're moving into step 4. Step 4 is to locate the value that intersects the horizontal axis. So if we figure out where the line crosses this horizontal axis, then we know the value that creates the 0 in our variable expression. So the first thing I'm going to do is I'm going to zoom out of this graph because it's going to be super zoomed in. I'm zooming out, and now you can see as I zoom out, here is our line that was just graphed. And what we have to do is we have to identify what this value is right here. We can't say definitively what it is, but when we move our graphing calculator feature over, and I'll extend this with this feature over here, okay, then we can begin to zoom in, and the units become more specific. So we're getting close. I'm moving over. Okay, now it looks like the line is crossing the horizontal axis at negative 32. So I think that this is my solution, but I'm going to verify it is using the table. Okay, so now I'm going to use the table feature to verify our solution is negative 32. So I'm going to click table, and where it says the x-intercept, I'm going to type in 32. And remember, we are looking for what value for p makes this left side simplify to 0. Well, we think that this value is negative 32. So what we should see in the table, for where the x is, we're going to put in negative 32, and then the y value, or the other value, should equal 0. And then I hit apply. And so now I can see when p is negative 32, and we plug that in, we get 0 for the other value. That means that we found our solution. So negative 32 is the only value that makes this equation true. So this is a one-solution equation. And one-solution equations will always have lines that are diagonal. So either there will be a positive diagonal line or a negative diagonal line. And we're trying to find that one place that it intersects the horizontal axis. And that place for our particular equation was when it was negative 32. So we can put it in set notation. Example